So let's look at a couple of very simple problems that we can solve using KSP. So for instance, if I have the compound cadmium hydroxide, so I probably want to go ahead and figure out what cadmium hydroxide is. Okay, so CdOH2. I know the KSP, I know the concentration of cadmium, so in solution I want to know what's the concentration of OH minus. So the first thing I always do is I write the reaction, okay? And the reaction is always the solid compound ionizing very slightly into its ions, okay? And then I go ahead and I write the KSP expression, okay? So that's going to be, like we did in the last video, the cadmium ion times the concentration of OH minus, and that will be squared because of the coefficient 2. And now all I have to do is plug in the numbers I have. So KSP is 2.5 times 10 to the minus 14. Cadmium is 1.5 times 10 to the minus 6. And the concentration of hydroxide is X, and it's squared. So if I go ahead and do the math and I solve for X, I find out that the concentration of hydroxide is going to be 1.3 times 10 to the minus 4 molar. And that's all there is to that. Okay? So that would be my final answer. So this is kind of the simplest version. We'll do another one just like that. Okay? So copper 2 arsenate. So copper 2 arsenate is copper is 2 plus, and arsenate is 3 minus, so Cu3, ASO4, 2. So we break that down and slightly ionize it to 3 copper ions, okay, and 2 arsenates. Again, I take the time to write my expression for KSP. So the concentration of copper ion, which is cubed because of the coefficient, times the concentration of arsenate, which is squared because of the concentration. Okay? And then I just go ahead and plug in my numbers. 7.6 times 10 to the minus 36. I don't know copper, so that's going to be x cubed. And then this is going to be 2.4 times 10 to the minus 4 squared. So if you solve for x, and make sure you know how to do that to get the cube root on your calculators, okay? I assume you probably do, but take a shot at it. You're going to get 5.1 times 10 to the minus 10 molar copper ion. Okay, so those are the kind of the simplest forms of this problem that you might see.